We can construct a single frequency network with multiple transmitter sites to overcome this problem of holes in the pattern of what is otherwise a single transmitter. Let's take a look at the topology of how that would work. We start out with a transmitter site and again multiple receivers. Let's introduce some obstructions. Those could be terrain, they could be buildings, for example. They could also be receivers that are moving that occasionally are obscured from the transmitter. Now, our transmitter is able to deliver a signal satisfactorily to some of those sites. They're fine. But how do we deal with the others? Well, that's where we're going to introduce a network of transmitters. We add 2 more transmitters, and we have them transmit the same signal at the same frequency, and now we're able to deliver a signal to each one of those sites. Everybody's getting a signal, and they're getting a signal, it's exactly the same signal, and it's at the same frequency. But in doing that, we've filled in those holes, but we've created another problem, because we now see that those new transmitter sites are also delivering a signal to receivers that were satisfactorily receiving from the original transmitter site. Those locations are receiving multiple copies of the same broadcast. How's that going to work? How are we going to make that fly? We're going to take advantage of the automatic equalization in a digital receiver, but in order to do that, we really have to adhere to the rule of a single frequency network. Every transmitter must be at exactly the same frequency.